In this lesson video, we'll be looking at Physics 1505, that is mechanics. Then today's topic is free body diagram, lesson 101. Let us start. This lesson video is meant to give you a crash course on how to determine or identify the forces which are acting on an object, and also be able to assist you on how to draw the correct free body diagrams. Remember that free body diagram, it assists us on how to identify the forces which are doing work to the object, the forces which are acting on the object. And then once you know how to identify those forces, then it will be very simple to answer questions based on calculations. The calculation might be calculate the mass of the object, calculate the acceleration of the system, calculate the tension. So those skills are actually originated from the free body diagram. By the way, this topic is under Newton's laws, specifically Newton's second law, where it deals with the force which is applied to an object and the acceleration which is caused by the force, and then it's directly proportional to the applied force and inversely proportional to the mass of the object. So the first scenario that we'll be looking at is when we have an object that is basically stationary, and then we have a difference between force diagram and free body diagram. Force diagram basically it's when you see the picture of the scenario, and then you also see the forces which are acting on the object. We refer this to a force diagram. Then looking at a free body diagram, it's something like this. We represent an object using a dot, and then we use tail-to-tail method. What do you mean by tail-to-tail method? It means the tail of each and every force will be from will be at this dot. This dot represents an object, remember? And then this will be our free body diagram. Then we know that the force that is applied by the surface, we call it normal force, and then we can say this is force applied, and then we can say this is Fg or weight, then this is kinetic friction. Basically these are the four forces that we'll be focusing on. Then let us look at the second scenario, whereby we have an object that is moving. This object doesn't experience any applied force. Nobody is pushing this force or anything that is applying force to this object, but is moving this direction. Then if this surface it's rough or there is friction, and then we want to draw force diagram. Force diagram will have Fg. Fg, it's a force that is always there. You should know that whether an object is on top of a surface or the object is off the surface. And then once the object is on top of the surface, just know that we have a force that is applied by the surface to the object. We call that force normal force. And then since there's no force applied to the object, so we cannot include force applied. And then we have this force which opposes the motion of a moving object. So whenever an object is moving, just know that we have this particular force which we call it kinetic frictional force. So drawing the free body diagram of this, we are going to have a dot, and then it's our Fg, it's our normal force, and then we have our kinetic friction. Since we don't know the magnitudes of these forces, so don't expect the length of these forces to be accurate. So this is a labeled free body diagram. Let us look at another scenario. Suppose we have this scenario whereby an object is actually pulled or pushed, but let's say this object is pushed this direction and this object is moving this direction. The surface is actually rough. So looking at the force diagram, we are going to have similar free body diagram like the previous one, but you should know that now there is force applied, then we are going to have an additional force, which is force applied. Then we have normal force, we have Fg, and then we have kinetic friction. Let us look at another scenario. Suppose we have this scenario here. We have a system that is connected by a string or a rope, and then this system is experiencing a force applied this direction. Someone is actually pulling this system this direction, and then the surface is rough. And then let's say this is A, this is B. Free body diagram of A, we are going to have 4 forces acting on the object. Free body diagram B, we are going to have 5 forces acting on the diagram. Now the first force will be our force applied. The second force, it will be normal since it's on top of the surface. Then we have Fg, and then we have kinetic friction. Remember, kinetic friction, it's always opposite to the motion of the object. It's not opposite to the force applied. Remember that as long as the object is moving and then the surface is rough, then we have kinetic friction. And do remember that the object can move while it doesn't experience any force applied. And then we have this force, which is tension. Remember that whenever there's a rope or a string, there is tension. And then how do you identify the direction of tension? Just know that if the system is moving this direction, there are tricks that we use to identify the direction of tension. Since the system is moving this direction to the right, and then looking at this object, we can say, where is the string? Is it in front of the object or behind the object? And then once you identify that, it will be very simple. If the string is behind the object, just know that the tension will be to the opposite direction. Now let us use the very same trick on object A. Now you can see that this is behind the object since it's moving this direction, and then this is in front. So it means that the direction of tension will actually be this direction. Now this is the front of this object, this is behind, then the direction of tension will be this direction. Then when we draw a free body diagram of object A, we are going to have something like this. This will be tension. Remember that what is causing this object to move this direction is tension. And then we have normal force, we have Fg, and then we have kinetic friction since the object is moving. I hope you can see how we identify these. Now let's say we have something like this. In this case, let's say this object is pushed this direction, and then it's moving this direction, and then we have friction. Now, to identify the forces which are acting on the object, we have Fg, and you should make sure that Fg is actually parallel to the sides of your page if you're using a page. Suppose this is your page, just make sure Fg is parallel. It cannot be this direction. No. And remember that Fg is always pointing downwards, vertically downwards. Whether the object is on a flat surface or the object is in the air, just know that it's downwards. Whether the object is going up, just know that the direction of Fg is always pointing downwards. Whether the object is on top of an inclined surface, just know that Fg is always pointing downwards. But you should take note with the normal force. Normal force is always perpendicular to the surface. So this is the surface, it will be perpendicular to the surface. It must form 90 degrees with the surface. and then we have force applied this direction. And then since there is kinetic friction, just know that we have, since there is a rough surface, just know that we have kinetic friction. Now jumping straight to free body diagram, we are going to have something like this. So this will be force applied, this will be Fg, this will be kinetic friction, this will be normal force. Let us look at another scenario. Suppose we have an inclined surface and then we have two objects, and then these objects are pulled this direction. We have 1 and 2. Now for 1, free body diagram, we are going to have something like this, which will be tension and force applied. Remember, we are applying force to this object, so it will have force applied. And then since it's moving this direction, it means in front we don't have the rope, but behind we have the rope. That is why it is this direction. And then we have kinetic friction, and then we have Fg, and then we have normal force. And then for the second one, basically we have there's no force applied to this object, so we are going to have force, it's tension, and then we have kinetic friction, we have Fg, then we have normal force. So it's very important that you be able to identify the forces which are doing work to the object, the forces which are acting on the object. Now free body diagram, it actually assists us to identify the forces which are acting on the object and the forces which are doing work. So in this chapter, the basics, know how to draw level free body diagram, and then we will go ahead and look at how to generate equations. Now let us look at this. We have 1 and 2. This system is pulled this direction. Now we do agree that if it's pulled this direction, it means the whole system will move upward. Free body diagram of 1. We are going to have, we can say this is T1, and then we have T2, which is this rope. And then since it's moving up, you can see that in front of this object we have tension, or we have a rope moving this direction. That is why it's T1. And then behind we have another rope, which is T2 going down. And then we have Fg. Don't forget Fg. And then for 2, we have, since T2 is in front of the system, so it means we are going to have T2, and then we are going to, there's no rope here, so we're just going to have Fg. So there is lesson 102 where we continue with this types of scenarios, and then we start generating equations. So just make sure you watch this lesson video and then gain the basic knowledge and the skills on how to draw labeled free body diagram. That's it for this lesson video. This is Wahula SJ. Thank you very much.